All right, folks, let's do a few examples here. We've got this question that says, conduct a one-sample hypothesis test at the 0.05 significance level to determine whether the mean of a population is 80 or not. 80 or not. It doesn't say less than 80. It doesn't say greater than 80. It says 80 or not. That's going to indicate our null hypothesis and our alternative hypothesis. Based on a sample size of 53, that means n is equal to 53, with a mean of 82, that's the x bar, that's our sample mean, and a standard deviation of 4.3, that is our s, that's our standard deviation, okay? So we're going to do the first step, state the null and alternative hypothesis. So we're going to say H sub O and H sub A. And our alternative hypothesis is that our population mean is very different from 80. Whether the mean of a population is 80 or not. And the alternative is it's not 80. And if the alternative hypothesis is that the population mean is not 80, then the null hypothesis is that the population mean is 80. And that's step one. We are done with step one. Now let's go on to step two. Is this a left tail, right tail, or two-tail test? Well, the equals or not equals tests are always two-tail tests. And so this is a two-tail test. Step three, state the level of significance and the p-value. Well, the question says, at the 0.05 significance level, so that means we're going to say that alpha is equal to 0.05. And now we're going to state the p-value. Now, in a two-tail test, we're going to split the alpha into the two tails. So we're going to put half of 0.05 in the left tail, and we're going to put half of 0.05 in the right tail. So we got to divide 0.05 by 2. So p is going to be equal to 0.05 divided by 2, which is 0.025. 0.025. That's our p-value. That's step three. Step four, select the test statistic. Well, because our sample size is 53, that's larger than 30, so we're going to use the z-statistic. Okay, so we're going to make this a z-test. Okay. Step five, identify the critical value of the test statistic. So we're going to identify our critical z-value, z-crit, and we're going to get that from a z-table. So here's our z-table, and what we're going to do is we're going to look up the p-value 0.025. We're going to look that up inside of the table, right? And if we look up inside here, a p-value of 0.025 is dead on at negative 1.96. So it's negative 1.96. But this is a two-tail test. And because it's a two-tail test, we're going to do plus or minus 1.96. So our critical z-values are plus or minus 1.96. Okay? That's the first part of step five. Now we're going to sketch the distribution curve. Let's go ahead and sketch that maybe right down here. Draw a line here, the x-axis. Then I'll put our normal curve here, a bell-shaped curve. It's a two-tail test, so I'm going to put a line here, and I'm going to put a line over here. And on this side, I'm going to put negative 1.96. And on this side, I'm going to put positive 1.96. And then it says shade the rejection region. So I'm going to shade the area in the tail on the left side, and I'm going to shade the area in the tail on the right side. And so there's two rejection regions, actually. There's a positive tail rejection region and a negative tail rejection region. So either one would show us that the population is not equal to 80. Okay? So we shaded the rejection region, and now we're going to state the decision rule. The decision rule is going to be reject H sub O if. Well, if what? This is a two-tailed test, so there's two things that can happen to reject H sub O. The first possibility is if Z is less than negative 1.96. And the other possibility is if Z is greater than positive 1.96. So if our z-statistic, if our test statistic comes up less than negative 1.96 or larger than 1.96, then we're going to reject the null hypothesis. That's the end of step 5. Now let's do step 6. Calculate the test statistic. All right, well, to calculate the z-statistic, we're going to do x bar minus mu. Okay, that's not a very good mu. Let's redraw that. Minus mu. That's not that much better, but it's a mu. X bar minus mu over S divided by the square root of n. Okay, that's what we're going to calculate. And we have all of these numbers right up here in the problem. There's x bar, 82. Mu is in the hypothesis, 80. S is the standard deviation. That's right here, 4.3. 4.3. And n, the sample size, is right here, 53. So we just got to fill in the numbers. So Z is going to be equal to 82 x bar minus mu, 80, divided by 4.3 is the standard deviation, divided by the square root of n, which is 53. And we're going to put that in the calculator. So we're going to type in. And what I do is I put parentheses. When I keyed in the calculator, I put parentheses around this, and then I put parentheses around this. So I'm going to go parenthesis, 82 minus 80, close parenthesis, divided by parenthesis, 4.3 divided by second square root of 53, close parenthesis. Now when I press enter, I get 3.38609. I'm going to go to two decimal places, which instead of 3.386 would be 3.39. And so my test statistic is 3.39. And I'm going to compare this number to my decision rule, which says that if the z-score is greater than 1.96, it is, then I'm going to reject the null hypothesis. So I'm going to make my decision, and my final decision is reject H sub O in support of the alternative hypothesis. And now this is giving me support for the study that I'm doing, and I'm now encouraged to go on and make a new hypothesis or the same hypothesis with a new study, new data, new sample, that sort of thing. Okay? Let's do another example.
All right, here's another example. It says conduct a one-sample hypothesis test at the 0.02 significance level to determine whether the mean of a population is more than 12. More than, not different than, but more than. So this is not going to be a two-tailed test. This is going to be a one-tailed test, a right-tailed test, because it says more than 12. Based on a sample size of 88, that means n is equal to 88, with a mean of 13.3, that's x bar, and a standard deviation of 6.3, that's our S, that's our sample standard deviation. Our first step is to state the null and alternative hypotheses. So we're going to state H sub O and H sub A. We're testing whether the mean of the population is more than 12. So that's our hypothesis. That's our alternative hypothesis, whether the mean of the population is more than, greater than 12. And then the alternative hypothesis would be mu is less than or equal to 12. No different than 12 or less than 12. That's step 1. So now step 2, is this a left tail, a right tail, or a two-tail test? Well, because it's testing whether it's greater than, that's a more than. And the right side of the curve is the more than side, and so this is a right tail test. Step 3, state the level of significance and the p-value. Okay, well, the level of significance, alpha, is 0.02, as stated in the question. But what's the p-value going to be? Well, what we've done always up to this point with greater than problems, or with more than problems, is we had to subtract the p-value from 1, because we know that a p-value of 0.02, that's going to give us a negative z-value, and we need a positive z-value. So what we're going to do is our p-value is going to be 1 minus 0.02, which is going to be 0.98. It's going to be 0.9800. That's what we're going to look up in the table. Okay? Step 4, select the test statistic. Well, because n is 88, because n is larger than 30, we're going to go with the z-statistic. And so now we're going to calculate, step 5, or not calculate, we're going to identify the critical value, the critical z-value. That's z-crit. z crit is going to come from the z table. And what I'm going to do is I'm going to look up 0.98 in the z table, and that's going to give me my critical z value. So here's my z table, and I'm going to look up down here somewhere, look up 0.9800. All right, there's 0.9803, 0.9798, that's closer. 0.9798 is at 2.05, 2.05. So my critical z value is 2.05. Okay? And now that I have my critical z value, I can sketch the distribution curve. I'll do that right here. There's a bell curve. And it's a right tail test, so I'm going to put a line over here, and I'm going to shade in the right side over here. There we go. And we're looking, this is the rejection region over here, and I'm going to put 2.05 at the cutoff of the rejection region. And now we need to state our decision rule. And our decision rule is going to be reject H sub O if what? If our z-score, if our z-statistic is greater than 2.05. And we only have one thing here, one condition for the decision rule because it's a one-tail test, it's a right-tail test. Okay? Last step here says calculate the test statistic and then make a decision. Well, the test statistic is going to be based on the formula z equals x bar minus mu over s divided by the square root of n. And we have all this information up here. So z is going to be equal to x bar. Our sample had a mean of 13.3 minus mu, while the mu we're testing against is 12, divided by the standard deviation of my sample, which is 6.3, divided by the square root of my sample size, which is 88, so square root of 88. And I'm going to punch all of this into my calculator and see what I get. So I'm going to do parenthesis. Remember, I'm going to put parentheses around my numerator and parentheses around my denominator. So I'm going to put parenthesis 13.3, oops, messed up there, 13.3 minus 12, close parenthesis, divided by parenthesis, 6.3 divided by the square root of 88. Close parenthesis, then I'm going to press enter, and I get 1.93572. I'm going to two decimal places. So if I round the second digit after the decimal by the third digit, 1.935 turns into 1.94. And so my z is 1.94. Now 1.94 is right about, let's say right here. There's my 1.94, which is not in the rejection region, and therefore I'm going to conclude my decision is do not reject H sub O. And what this means is that my data that I gathered does not give me significant evidence that my alternative hypothesis is going to receive support. So it's possible that my hypothesis is just fine and that there was something wrong with the data. And that's why it's so important to get a good, to gather data in a how do I say this? Gather data in a way that you get a good random sample that is representative of the population that you're getting at. You could probably spend years just studying how to gather good data. Okay, but if your data was good, then it's possible there's just something wrong with your hypothesis, and you're basically chasing down something that isn't worth chasing down. And you may want to consider just moving on to a different subject, a different hypothesis, a different set of variables. Okay, so there's a second example. I think we should do maybe just one more example. All right, let's do this last example here. Conduct a one-sample hypothesis test at the 0.01 significance level to determine whether the mean of a population is less than 100. Less than 100. So this is going to be a left-tail test because we're testing whether the mean of the population is less than a value. Based on a sample size of 72, that's our n, with a mean of 95, that's our x bar, and a standard deviation of 15.3, that's our sample standard deviation. Step 1, state the null and alternative hypotheses. So we're going to put H sub O and H sub A. And so our alternative hypothesis, we're testing whether the mean of the population is less than 100. So we're going to hypothesize that the population mean is less than 100. And if that's our alternative hypothesis, then our null hypothesis is going to be mu is greater than or equal to 100. Step 2, is this a left-tail test, a right-tail test, or a two-tail test? Well, it's asking that we're testing whether the population is less than 100. Less than is on the left side of the distribution curve, and so this is a left-tail test. What is the significance level? Well, the question says that the significance level is 0.01, so alpha is equal to 0.01, and since it's a left-tail test, the p-value is the same. It's equal to the alpha. So p is equal to 0.01, and now we're going to select the test statistic. Well, because n is 72, and because 72 is greater than 30, we're going to go ahead with the z-statistic. And now we're going to move on to step 5, identify the critical value. We want the critical z value based on a p value of 0.01, so we're going to go into the z table. We're going to look up 0.01. It's going to be over here somewhere. 0.02, 0.01, 0.096, 0.99, and 0.102. 0.99 is closer, and that's negative 2.33. So, negative 2.33, negative 2.33. And now we're going to sketch the distribution curve and shade the rejection region. It's a left-tail test, so over here we're going to draw a line here, and we're going to put negative 2.33 as the critical z value, and we're going to shade in the rejection region here. Shade in the rejection region. And we're going to state the decision rule. Reject H sub O if. Now, there's only one rejection region, so we're only going to have one condition, and that's if the z value that we calculate is less than negative 2.33. That's step 5, and now let's move on to step 6. We're going to calculate the test statistic. Well, z, our formula, is x bar minus mu divided by s divided by the square root of n. All that information is right up here. So, our z statistic is going to be equal to x bar, and we have a sample of 72, sample size of 72 with a mean of 95. So it's 95 minus the population mean, we're testing against 100, so we're going to put a 100 here, divided by the standard deviation of the sample. Standard deviation is 15.3. 15.3 divided by the square root of the sample size, and the sample size is 72. So divided by the square root of 72. And we're going to put parentheses around these in our calculator to make sure we don't mess up the calculation. So I'm going to go parenthesis 95 minus 100, close parenthesis, divided by parenthesis 15.3 divided by the square root of 72, close parenthesis. Press enter, and we get negative 2.77296. And so we're going to go to two decimal places. We got negative 2.772. That third digit is a 2, so we're not going to round up. So we're just going to stick with negative 2.77. And so our z statistic is negative 2.77, which is less than negative 2.33, and therefore we're going to make a decision. We are going to reject the null hypothesis. Reject H sub O. And that's our final, that's the end of our last step, okay? All right, so hopefully these examples have helped you begin to learn the procedure for testing a hypothesis. If you are going to wind up being a scientist, this is just the beginning of your journey on learning how to test hypotheses. And you should get a lot of training, and you should learn from a lot of people on how to do this. This is just the beginning of your world, learning how to discover the truth of the things that we examine and the things that we investigate, okay? All right, in the next class, all we're really going to do is we're going to do the same thing in the next class, only we're going to do a lot of examples where we use the t-statistic instead of the z-statistic.